Yeah, they're opposite each other. So vertical angles are angles on opposite sides of an x. So angles 1 and 2, those are vertical angles. I could also place angles 1 and 2 if I wanted to here and here, and those would be vertical angles. So or I could say those angles 1 and 2 are vertical, and then I could put in a 3 and a 4 on the other, and the 3 and the 4 would be vertical. Anytime you make crisscrossing line segments here, you create vertical angles and also linear pairs of angles, complementary, supplementary, all kinds of things. Well, it could be complementary, but supplementary angles if they're a linear pair. All right, so linear pair. Whoa. No. All right, so here we go. A linear pair is two adjacent angles that form a straight line. So two adjacent angles that form a straight line. So something like this. If I drew a picture of that, I might have my 1 and 2 next to each other instead. So two adjacent angles that form a straight line. Make a linear pair of angles. And then complementary angles, two angles that add to 90. Supplementary, two angles that add to 180. That's it. So complementary definition is a little more generic. They don't have to be next to each other. They don't have to be part of a right angle. They just are two angles that add up to 90. Supplementary, they don't have to be next to each other. They don't have to be a linear pair to be supplementary. But every linear pair is supplementary because they always add up to 180. So there's a little theorem that says that vertical angles are always congruent. Vertical angles are always congruent. So I'm going to run you through not a full proof, but we'll call it a plausibility argument here. I'm going to draw a picture here again of a couple of vertical angles here. So we have angles 1 and 2. We're going to demonstrate or prove to you that those two angles have to be congruent. So we're going to say that angle 1 is congruent to angle 2. That's what we're trying to prove here. And here's the idea. We're going to use the idea of a linear pair and supplementary angles to prove that. So I'm going to place in here an angle 3 that are going to be used or paired with 1 and then paired with 2. So here's my plausibility argument. When you do a proof, you don't want to use the theorem to do the proof. So the theorem we're trying to prove is that vertical angles are always congruent. Here's why. Would you agree that angle 1 and so angle 1 and plus or and angle 3, we'll say and angle 3 are a linear pair. Do you agree that angles 1 and 3 are a linear pair?
Yeah.
How do you know?
Because they're on the same. What if they share a line?
They share a line. Would you also agree that angles 2 and 3 are a linear pair?
Yes.
So what does that mean? The measure of angle 1 plus the measure of angle 3 must equal if it is a linear pair.
180.
180. A linear pair always has the measures of the two angles that add up to 180. So would you agree that both of these then, measure of angle 1 plus measure of angle 3, if that equals 180, and measure of angle 2 and measure of angle 3 also equal 180, then they are equal to each other. So measuring 2 plus measuring 3. So the idea is that, let me erase those. So measure of angle 2 plus measure of angle 3. So measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Do a little algebra there. What can you subtract off of each side? Measure of angle 3. If I subtract measure of angle 3 from each side, I get measure of angle 1 equals measure of angle 2. If the measures are equal, the angles are congruent. You could do that for any vertical angle that you draw. So that's the idea. We use the idea of the linear pair to prove that the vertical angles are congruent. So you should be able to walk me through that in words and diagrams. We're not officially doing a two-column proof or anything yet, but you should be able to follow through that argument and be able to explain it on your own. So if vertical angles are congruent, what's the measure of this angle over here? 80 degrees. As a matter of fact, when you have two crisscrossing angles, if you're given one of them, you can find all four. So it's kind of four for the price of one. You're going to get into some problems here where they're going to ask you to do some algebra using that idea of either vertical angles or a linear pair. In this case, I think it's better to start with the idea of a linear pair, because if I look at vertical angles here, I have a mixture of variables. I'm setting a y plus 20 equal to an x plus 15, and that's going to be problematic to solve unless I bring another equation into the mix and use substitution. I don't want to do that. But would you agree that if I take these two right here, they should add up to 180, right? Because they are a linear pair. So I'm going to start with that. 3x plus 5 plus x plus 15 has to equal 180. You're going to find from this point on, we're going to have a lot of equations that we set up, and they're either going to be equal to each other or equal to 180. That's going to be like 80%, or I don't know, a high percentage of our equations. Like if I had to guess on what the equation is for setting up and solving for a variable, check it out. We're going to set it equal to 180, or 15. So set these two, add them up, equal to 180. We're going to add 3x and x, that's 4x, plus 20 equals 180. Go ahead and subtract the 20 over. We're going to subtract 20 from each side. 4x equals 160. Divide by 4. So x equals 40. So x equals 40. So if I want to find the measure of each of these angles, I know I can put 40 in here. It's 40 plus 15, plus sign there. And that's going to give me 55 degrees. So if that's 55 degrees, I don't even need to plug it into the other one. I could just subtract 55 from 180. I think that's probably more efficient than plugging in 40 for x. But either way, 125, right? So this is 125 degrees here. And now I can use the fact that vertical angles are congruent to get an expression or an equation right here. If that's 125, this down here is also 125 degrees. And if this over here is 55, so is this. It's also 55 degrees. So now I know all four angles all the way around because of vertical angles and linear pair. Now, they're also going to ask me to find y. Probably the easiest equation to solve for y would be this one right here. Y plus 20 has to equal 55, right? Y plus 20, I'll write it in a different color here. Y plus 20 has to equal 55. Could I have done that in a different way? Guys? Yeah, I could have. I could have set 4y minus 15 equal to 125. Or I could have taken these two expressions with y in it and added them up, set them equal to 180. There's lots of different ways to get y. But if I know that this y plus 20 angle equals 55, that's probably the easiest way to do this. Subtract 20 from 55, I get y equals 35. And I've got my x, I've got my y, I've got all four angles, and I'm set. This is the last one on here. It says if angle A is 38 and is complementary to C, what is C? Complementary means adds up to 90. So at 90 minus 38 gives me my angle C. 52 degrees. 52 degrees for C. And then in part B there it says if T is 6x minus 1 and R is 5x minus 17 and they're supplementary, then go ahead and find angle T and R. Well, if they're supplementary, then they have to add up to 180. A lot of students will put these in parentheses. I don't end up needing the parentheses. I can drop them right away because I don't have to do any distribution in my solving. Okay, so I have 11x minus 18 equals 180. And add the 18 over, 11x equals 198, and then divide by 11. How many times is 11 going to 19 with once, with 8 left over? 11 goes into 88 times, so x equals 18. And then I have to plug in the 18 for x in each of those other two examples there. So if I plug in the 18 here, what do I get for t? Was it 107? 107. And then what does r have to be? I don't even have to plug it in. R, I know, has to be supplementary with 107. So 73 degrees. 73 degrees. Good. Let's go ahead and step away. We'll do C tomorrow. All right, and then we have on here for part C, x is supplementary to y and y is complementary to c. If x equals 4x and y equals 2x plus 18, what is the measure of c? So we got x is supplementary to y. So we've got 4x plus 2x plus 18 has to equal 180. If we solve this for x, we've got 6x equals 162. So x equals 6 goes into
Eli Sabat and Caden Beaker, please report to the attendance office.
So x goes into that twice. Oh, 42 left over. 7. So x equals 27. And it says, what is the measure of c? So c is complementary to y. So if y equals 2 times 27 plus 18, we get y is 54 plus 18, 54, 64, 72 degrees. If z is complementary to y, then angle z has to equal 90 minus 72 or 18 degrees. That's putting together the complementary and supplementary. All right.